Thank you and welcome to this talk. This talk is about generating own stuff with the Angular CLI and schematics. And I am Manfred. I am a trainer and consultant for Angular. I'm doing a lot of in-house consultancy and trainings. And I'm also part of the Angular, not of the Angular, of the Google Developer Expert group. In addition to that, I am also the founder of Angular College, where I and some colleagues of mine are doing some workshops and consultancy. So, one question for the beginning. Have you ever tried to set up a modern JavaScript project by hand? Who has tried this? Yeah. And who had fun with it? Not that much, okay. It isn't that fun at all when you have to do all those stuff by hand, because you have to take care about the compiler, about your TypeScript compiler, for instance. You have to take care about the package manager and packages in general. You have to build a build chain that is optimized for bundle sizes and performance. You have to include testing tools and also something like test coverage analysis. And you have, of course, to include linting tools, and so on and so forth. So, as you see here, that isn't fun as well as it isn't easy at all. But we are lucky. We have the Angular CLI, and the Angular CLI is doing this for us. To use the Angular CLI, as you might know, you just have to call ngNew. ngNew is creating a new project, and then you can use ngGenerate to create new components, to create new services, to create new models, and so on. And now the question arises, if we could use this for custom stuff, if we could tell the CLI to create a project with custom templates that align with our own content identity, corporate identity. Or if we could just create an on-menu component or some other components we need on a regular basis. And this is exactly what this talk is about. In this talk, I will introduce schematics. I will show how to use schematics to do this. I will show how to create custom schematics for custom stuff like own menu items, own CRUD forms, and so on. I will show you how to use parameters for code generation, as well as how to use templates. And in addition to that, at the end, I will show you how to scaffold a whole project for a CRUD use case. So let's start with schematics in general. Schematics is the tool used by the CLI to scaffold stuff, to scaffold components, modules, and services. And it is also the name of the project behind it. In addition to that, schematics is also the name of the code generators created with it. So the name Schematics is used for both, as you see here. And in addition to that, there is another term that might be interesting for you. This term is called collection. A collection is nothing else than a set of schematics. A set with code generators that belong to each other. One word of caution, schematics is currently experimental. That means that the public API hasn't been stabilized, and that also means that there could be breaking changes. Nevertheless, try it out, give it a try, report feedback, or use it to get quicker started with your own projects. And so did other guys and project teams. For instance, the cool guys at Norval created something that is called NX. And NX is both. It is a library, but also a code generator leveraging schematics to create a so-called workspace. A workspace is an environment based upon the CLI that allows you to do the monorepo approach, which allows you to have several projects at once, several projects that belong to each other. On the other side, the people behind ngRx also published a schematics project some weeks ago. It was at the beginning of this month. And it allows you to generate all the boilerplate you need for schematics. One thing that is nice with schematics is that schematics are atomic. That means they work like a database transaction. When you are generating code, you don't modify your files on the hard disk. Instead of this, you are modifying your files within a staging area. Within the staging area that is represented by a tree object, you can modify existing files or you can add new files. Of course, you can also delete existing files. And when you say, okay, now everything is okay, then you can commit your transaction that you can write back everything to your hard disk. This is quite important because this guarantees that it isn't possible that something breaks in the middle, and it guarantees that it isn't possible that your project is left behind in an unwell-known state. You can transition your project from one well-known state into another well-known state, into another consistent state. So, of course, the question arises now how to create an own schematics project. And the answer is to create a schematic, you can use, what do you think? A schematic, that's right. Well, you just need to install this tool here that is called Schematics CLI, and then you can scaffold a new schematics project using schematics blank. In addition to that, there is also the possibility to use schematic to create a new project with some sample code. The sample code is quite nice to learn schematics. It contains a lot of stuff and also a lot of comments that tells you how to use everything. Yeah, here you have some sample schematics within this project. This is how it looks like when you are scaffolding a blank schematics project. As you see here, it just looks like scaffolding an Angular application. You get several files generated, and then some libraries are npm installed. And now there is one important thing. I call it Manfred's first rule of surviving schematics. You need to make sure that you use exactly the same versions as within your CLI-generated project. You have a huge problem when your schematics project uses other versions than your CLI-generated project. So please just align your def dependency. For instance, here I'm using the def dependencies I had found within my CLI project. I've scaffolded with the CLI 1.6.8. And then, of course, you have to npm install everything. When you look into your schematics project, you see a project structure like this. And when you look closely at this, you see this is more or less an npm package. You have a dsconfig JSON, you have a package JSON, and you have a nodes modules folder. And one important thing here is that the package JSON is pointing to a collection JSON. And this collection JSON in turn is describing all your code generators, all your schematics. Normally you have an own folder for each schematic. That isn't a rule, but it is quite common. When you look into the schematics for the Angular CLI, you will find this pattern. And each schematic comes with a so-called rule factory. The rule factory is creating, as the name implies, a rule, and the rule is just doing the code generation. This is what the rule factory looks like. It is just a function. The function takes some options. The options are the options you are passing at the command line when you are calling the schematic, and the return value is a rule. And this in turn is also just a function, and this function takes the tree. As you've heard before, the tree is representing your staging area, and it takes a context object with some additional stuff. For instance, as you see here, the context contains a logger you can use to log out some information. And with the tree, you can create some new files, for instance. Here, because it's such a nice habit, I'm creating a hello.txt file with the contents hello world. After that, of course, you want to test your schematic, and for this you have to build it. Just run npm run build, and then you can run schematics with the name of your code generator, with the name of your schematic. Here I'm using point and hello world. Point means that the schematics collection is the current project, and hello world is the name of it, the name of my code generator. You can also test it within another project, for instance within a demonstration project. For this you need to npm install your schematics collection, or you could also link it by using npm link. And then you can use the schematics tool one more time. The first word you are appending here is the word of your collection, the name of your npm package, and the second name is the name of your code generator. Both here is named hello world. And instead of schematics, you can also use ngGenerate, which is more or less the same, but it's the Angular way to do things. So let's have a look at this. Let's try this out. I have prepared a simple hello world application. You know, green is the hope, as we see in Austria and Germany. And within this collection, I have, of course, a package JSON, and as you see here, the package JSON has this very special entry point that is pointing to my collection. The collection JSON is describing the collection, and within here, we have, for instance, my hello world schematics, and yeah, it has a description as well, a factory. The factory is called hello world. It's located within the index file, and when we look into the index file, we have our factory, which is returning the rule, which is in turn creating our file. Okay. Let's switch to the console and let's build everything, npm run build. And then let's run it. Let's try schematics with dot and hello world. I'm lacking an S. Okay. Now we see it is working. I've got my debugging information and I've got a hello.txt. So let's have a look inside the hello.txt. And as you see, there is nothing. So for some reason, I didn't get a hello.txt. The reason for this is when I'm using schematics within a schematics project, pointing to it with a dot, then schematics run in the debug mode. And the debug mode means that nothing is written to the hard disk. I'm getting a dry run. Everything is executed in the main memory, but nothing is written to the hard disk, which is most of the time what you want when you want just to test it. Just think about database tests. It is quite common to do a rollback at the end of a database test. Because of this, I will switch off the debug flag. Let's set debug to false. Let's set debug to false. And now I get my hello world written to the file system. Nice thing. So much for this first introduction. So now let's go one step further. Let's talk about parameters. Normally when you want to generate code, you want to pass some parameters to tell the generator how it should do its job. And for this I want to switch to a more exciting demonstration, a demonstration that is generating a menu component. This menu component consists of several files. Of course, there is an Angular component called, for instance, side menu, but there is also a side menu item describing the items of the menu, and there is a side menu service which is providing all the items, which is telling the component which items to display. And here I want to define that the side menu item as well as the side menu service is optional. When I'm not creating it, then the side menu component shall just display some hard-coded menu items. When I'm generating it, then the side menu component shall ask the service which items to display. And for this, I want to have a command like this. Something like ngGenerate with the name of my schematics, navigation menu, for instance. I want to append the name of my menu. It's here called side menu. And I want to add a flag that tells the code generator whether this service shall be generated or not. When we look into the structure of our schematics project, we will see one time again that we have an NPM package. We have a package JSON with a node modules folder and with a ds-config JSON. And one more time, the collection JSON is describing everything. For instance, it is describing my menu schematic. Within my schematic, I have one more time a rule factory, and I have two more files describing the parameters I'm allowed to pass. For instance, here is a schema JSON containing a JSON schema. That's my most favorite sentence within this talk. Please try to say it, the schema JSON with the JSON schema. Try to say it. At 3, 1, 2, 3. Yeah, that's perfect. The schema JSON with the JSON schema. And as you can imagine, it just contains some JSON schema that describes all the parameters that are allowed here. And then we have the schema.ts file, and it contains the same, but in the form of a TypeScript class. This is what it looks like. It just contains property for all the parameters, and some of the properties are automatically passed by the CLI, and other parameters are custom parameters, like this menu service flag here. Well, when we look into our project, we will see that there is another rule factory, and now this rule factory gets this menu options object containing all the parameters. So my rule can look into it, and so my rule can find out which options have been passed. Of course, when we want to create such a side menu component, we don't want to write everything with TypeScript. We want to use templates that tell the generator how a component class looks like, or how a component template looks like, or how the service looks like. And for this, I've created a folder files. It is not a rule to have a folder with the name files, but it is very common. When you look, for instance, in the schematics for the Angular CLI, you also find a folder files. And within this folder, you have templates like this one. And I think you have seen something before. This looks a bit like, I would say, a PHP file. Who has done PHP before? Yeah, some of you. Who has done ASP before? ASP.NET? Yeah, it's all more or less the same. You have your code that you want to generate, and you have some procedures that are executed, some procedures within placeholders that are rendered out to the page. For instance, here I have my delimiters, and within those delimiters, I'm using the past property name. This is the name of my component I want to scaffold, for instance, side menu or top menu or bottom menu or something like this. And I'm also using a function. The function is called classify. Classify is formatting the name so that it fits for a class name. You know, when you are defining class names, you are using most of the time buscar case, for instance, and you aren't allowed to start with a number. Classify is taking care of this. One nice thing about templates is that the template name itself is a template. The template name itself can contain some placeholders. For instance, here I'm using the placeholder path. You just need to write it between two underscores. Or here I'm using the property name, the placeholder name, which contains the name of the component I want to generate. You can even use functions within your file names. For instance, here I'm using the function dasherize. Dasherize is just taking the name. The name is piped into dasherize, and dasherize is formatting this name so that it fits for a file name. You know, normally we are going with kebab keys when defining file names. So how to call a template? We need one more time a rule factory returning a rule, and then we need to define a template source. In the world of schematics, a source is just something that flows into your tree, that is just taken into your tree. And in my case, the source bases upon every file within the files folder, and those files are piped through those functions here, through the filter templates function, through the template function, and through the move function. As you can imagine, the filter templates function is just filtering the templates. It is deciding upon whether we need the service or if we just want to go without the service. The template function is just executing the templates, all the templates that can be found and all the templates that aren't filtered. And this template function gets some properties passed. For instance, I'm passing all the command line options so that I can use them within the templates. Within this options object, you find something like the name of your component you want to scaffold, as well as the path thing we have used before. And within my string utils, I have all the functions I've called before. For instance, the dasharize function, but also the classify function. One important thing here, I'm using the spread operator, which means that not the options object is passed and not the string utils object is passed, but every property within those objects are passed. For instance, as mentioned, the property dasharize or classify, as well as the property name and path and so on. All the properties get passed to the template. Yeah, and then we need to move everything to the right folder, to the current folder. For this I'm calling the move function here. Move is also replacing the placeholders within the file names. Yeah, and when we have this template source, we can construct a new rule. Before I've written an own rule, but normally you are just creating a rule by chaining existing rules. And that is what happens here. For instance, here I'm just taking the chain rule, which is chaining other rules. And so I'm chaining the branch and merge rule, as well as the merge with rule. At the end of the day, this is just branching my tree within the main memory, like you would branch a Git project. Then everything is written into this branch. My template source with all the executed templates is written into this branch, and then everything is merged back to the tree object. And at the end of the day, my tree is written to the hard disk. Okay, nice. By leveraging this, we can quite easily generate a main menu. But I think we should go one step further. It would be nice to have some schematics which scaffold a whole application. This is what I want to scaffold. I'm doing a lot of CRUD stuff because I'm doing very much in the field of business software, and as you might know, such a business software contains a lot of CRUD forms. And my idea is to create something like this, to generate something like this, a form that allows me to search for some entities and that lists my entities, and then I want to select this or that entity to get a detail view. This is what I want to generate. And as a matter of fact, we can use everything we have learned so far to accomplish this. But we should also think about our project process. We should think about things we need in addition to schematics. For instance, first of all, it would be a good idea to create an example that is covering all the cases I want to generate with my code generator. An example that is respecting all the data types and the types of filters and the types of entities and relations I want to respect with my code generator. Then we need to find the variation points, the things that differ, the things that changes when I'm generating a project with it. After this, we need to define a model for our variation points. For instance, a JSON object that contains every information we need to generate our custom stuff. Each information we need to tell the code generator so that it knows what to generate, so that it knows to generate something for flights, or something for hotels, or something for invoices. And then, of course, we need to write the code generator and test it. So one thing that I found out is that it is good to take some time for the first example. Take some time for it and review it carefully, because this is what you get when your code generator has been built. This is what your code generator will generate out. And of course, you don't want to find out at the end of this chain, which takes some effort, that you need something different within your generator. You want to align with best practices here. And in addition to that, it is also a good idea to embrace libraries and components. Make sure that your example is as tiny as possible. Make sure that you are generating as less code as possible. Because every line of code, even every generated line of code, needs some amount of maintenance, and it is increasing the complexity of your project. So make sure that it is as tiny as possible. Don't create a code generator that is generating a data grid. Create a code generator that is generating a file using an existing data grid. You don't want to duplicate your data grid code in your project. Okay, I have done this, and I want to show you a simple demonstration for this. Let's move to my CRUD demo. Here I have a model JSON file, and this model JSON file contains everything we need to know to generate a CRUD use case. For instance, the title of our use case, the name of the entity, it contains the API, it contains also the fields I want to filter. Here we could append some names of controls we want to use to create a filter, and it contains a description of all the fields I have. Of course, we could generate this out of Swagger, of a Swagger description. For this, we just would leverage another schematics. Okay, and now let's run this. Here, as you see, I'm running ngGenerate CRUD module with a name, the name of my entity, and I'm telling my code generator that I want to use my own schematics project. Not the default schematics from the Angular team, but my own schematics project. And as you see here, a lot of stuff is generated. Stuff that would bring a lot of effort when we would have to write it by hand. I'm getting my edit component, I'm getting a class for defining a filter, I'm getting my list component, I'm getting a module, my routes, as well as a service and an entity file. Okay. So what's the current state of this idea? The current state is that I've written this and I've published it to NPM. So you can grab it from NPM and you can use it as is, but you can also fork it and change it so that it fits better to your project, so that it aligns better with your corporate identity or with the design of your very application. And if you like, you can also contribute to it. I would say, let's join forces to create something bigger. Let's use the power of the community. When you want to dig in further into this topic, there is a very nice introduction written by the Angular team, by Hans Larsen, the father of schematics. You find it behind the first link. I myself have written a tutorial that consists of 3 articles so far. I think there will be some more articles, and it shows how to write this menu schematics I have showcased before. And of course you can use and fork and modify my NPM project, my Angular CRUD generator. So let's come to a conclusion. We have seen that we can leverage schematics to automate boring tasks. We have seen that schematics is the official solution in the world of Angular. There are some existing projects out there leveraging schematics, like the CLI itself, NX or ngRx are also using schematics. We have seen we have a staging area. This avoids to destroy something when something bad happens. We have also templates and rules. We can create our own schematics or tweak existing one, and I want to encourage you just to try it out to automate all these monotonous tasks you might have. So much for me. Thank you for coming and have a nice conference. Thank you.